Welcome to this section in Mastering Elasticsearch 5.0 entitled Tips. In this section, we round out the course with a few helpful tips. First, we start with production tips. We then look at some helpful tips for securing your Elasticsearch cluster. Welcome to this video entitled Production and Security Tips. Now let's take a look at some of the useful production tips that can make monitoring your cluster a lot easier. Let's start with the JVM heap. As Java is a garbage collection language, it's imperative to remain cognizant of how memory allocation affects garbage collection cycles. If the heap is too low, you risk out-of-memory errors. But resist the urge to set the heap too high because this could result in long garbage collection cycles. In the most extreme case, you get a stop the world pause where nothing in Elasticsearch is functional until garbage collection is completed. This is a recipe for disaster. Monitor your heap. If you observe high usage, say 85% or more, along with a short drop of maybe 10% usage to 75% during garbage collection, your heap is too small. Conversely, usage of maybe 65% with garbage collection resulting in long reductions, maybe from 65 down to 5%, would indicate that the garbage collection cycles are too long and thus the heap is too big. Resist the urge to add a bunch of shards. In an ideal world, you would increase shards in phases. To figure out the best number of primary shards to begin with, set up a test cluster with one shard that will ingest real-world data based on your requirements. And you can use the configurations that we gave you in a previous video regarding an example of a cluster setup as sort of your baseline. To figure out the best number of primary shards to begin with, set up a test cluster with one shard that will ingest real-world data based on your requirements. Dividing the total data requirement by the capacity of this one shard should give you a rough idea of how many primary shards you need. This is a baseline. The purpose of this test is to insert and search real-world documents that you'd be using in production. Ideally, you want to do this until your cluster breaks. Such capacity planning is very important before going into production. Resist the temptation of making one big index. The first inclination is to assume that searching one index is more efficient than searching multiple indices. But in Elasticsearch, this is not the case. In fact, the net effect is actually the same. However, adding new data to a large index does incur a lot of overhead. As such, leverage aliases to create new indices. In doing so, you can add new data to a new index without having to change anything. Just simply add the new index to the alias, and that's it. It becomes searchable. Removing older indices also becomes easier. Instead of having to bulk delete data from one index, which is only marked for deletion initially in Elasticsearch, you can actually delete the whole index, which results in immediate deletion. So if you want to remove the data, it's just a matter of deleting the index instead of deleting data from an individual index. Finally, other ways to manage indices include using time-based indices, like we see in log/log analysis, and usage of hot-warm architecture to separate data based on usage, with hot data being accessed the most. Elasticsearch lets you use a parameter to label an index as hot, warm, etc. And this is quite useful. And if you want to update that index label from, let's say, hot to warm, you simply do the following. Here, I'd like to offer some helpful tips to ensure that your production cluster isn't compromised. One common occurrence in the hacking world with Elasticsearch clusters is called ransacking. This is basically when web-facing clusters are compromised, with all the indices being removed and replaced by one with a ransom demand. Openly accessible Elasticsearch clusters on the World Wide Web is an absolute no-no. The first tip involves the extreme case of disabling HTTP access on all nodes except client nodes. Because Elasticsearch uses transport interface to communicate internally, this is often suggested as the ultimate way to secure a cluster on the web. With this HTTP access, and Elasticsearch APIs by extension, will only have access to client nodes. This allows for search requests from the web. However, and be mindful of this, you will not be able to use the cluster APIs to gather monitoring data on all other nodes, master node, data node, etc. An alternative and viable solution is to leverage IP filtering and block out all HTTP access to your cluster except from specified IP addresses. When telling which IP addresses to listen to, with your nodes being HTTP enabled, of course, you should listen to private IPs only. This is the network.host setting in your elasticsearch.yml configuration file. Another mistake to avoid is communicating directly to your client node from the web. This exposes document and index structure. A better method is to use a server-side software to receive web client requests, which can then be securely validated and converted to messages that can be fed to your client node. Another good practice, if possible, is to isolate Elasticsearch clusters from other parts of your network, essentially creating a private network. In the AWS world, this will be like putting your cluster in a virtual private cloud with different security groups. Finally, if for some reason you require a public-facing node, say for access to tools like Kibana, and using VPN, the most viable option, isn't possible, be sure to put a proxy between the public and your node. Obviously, secured HTTP, which is HTTPS, is required in this scenario, as all transmissions should be encrypted. And that concludes this video. Up next, we round things up.